Okay, we're going to go over the lab from Tuesday, um, and we're going to explain why our data was bad, and I'm going to give you some new numbers from when I conducted the experiment again after class. And then I'm going to go over what you should be doing today um, uh, for your kitchen chemistry at home lab. Okay, so let's look at the data from yesterday. And if you remember, Q of the water is going to equal the negative Q of the aluminum. Which means mass times the specific heat times the delta T is equal to the opposite of the mass times the C times the delta T. Which means on our aluminum, because its temperature is going to decrease, it has a negative delta T, those two negatives cancel out. So I tend to just drop my worrying about that right now. So mass of the water is 50 grams. My C for water is 4.186 joules per gram. And my delta T was 7.5. And so that is equal to the mass of the aluminum, which was 24.1 grams, times our C, which is what we're looking for, times our delta T, which should have been, again, it should have been negative 47.6. But again, since the whole thing's negative, then those two negatives cancel out. So to rearrange the equation, you divide both sides by 24.1 times 47.6. 24.1 times 47.6. And when you figure this out, you come up with C is equal to 1.4. And if a few of you stayed after class, we looked it up, and the answer we should have gotten 0.9. So now we need to figure out how close were we. And so we're going to do what's called percent error. And so to calculate our percent error, we have to know our theoretical. So we look that up. And you will do the same thing for the copper. The theoretical is 0.9 for aluminum. And our experimental, and this experimental was 1.4. It's actually 1.36. However, if you look back at our data, that would have been 3 units, and we did not have 3 units of precision, so 1.4. We only had 2 significant numbers. So the formula for percent error, and I believe this is on the formula sheet, but it's experimental minus theoretical, and it should be the absolute value of experimental. For theoretical, you cannot have a negative percent error. So the experimental was 1.4. The theoretical was 0.9. And divided by 0.9. And I believe I came up with let me double check. Okay, so when we do that, then our percent error is 55%, which is high. But again, considering our apparatus that I used and a couple other minor details, uh, that's not unexpected. If we were in a true scientific setting, that would be unacceptable. However, considering what we had to work with, that's acceptable. Okay, so causes of error, our equipment. I already discussed our equipment. Procedures, did I follow the instructions perfectly? And part of the procedure, and it kind of ties in with the equipment, is particularly with the water, when we were getting the final temperature of the water once we put the aluminum in there, because the mass, even in the second one, the mass of the aluminum, it was such a slow heat decline, temperature decline, that it was hard to tell when it quit declining because the aluminum was put in there and when it quit and when it was just trying to get down to room temperature. And again, that's part of because our um, the calorimeter that we made with the styrofoam cups did not hold the heat in very well. Um, it was easier to tell that ending point when I used a higher mass of aluminum. One of the other things is, had we used aluminum beads, more like BBs, then it would have worked better because the surface area would have allowed the heat to leave faster. Um, so equipment and procedures, those are the two things that are um, the main causes of error. So you just need to figure out where in the equipment can you make improvements and where in your procedures can you make improvements. Okay, so your kitchen chemistry lab. The assignment is posted on Canvas. The purpose and the intro is pretty much already done for you. I just went ahead and left that on there. So you're going to design an experiment similar to what we did to test whether or not a group of pennies might or might not be made of copper. And you're going to use two groups of pennies, some that were minted before 1982 and those that were minted after 1982. And you're probably going to need 4 or 5 pennies of each group. Make sure that your data is clear enough, not your data, make sure that your procedures are clear enough that I can replicate the experiment. If you are able to conduct the experiment on your own, please do so. If you do not have the resources readily available, remember I told you I don't expect you to go be buying meat thermometers and all that kind of stuff. But if you have that stuff available, then please conduct the experiment. If you don't have it, try and talk to your classmates and see if they will let you watch. If you still can't find a classmate to do it and collect their data, then you can talk to me and we'll set up a day after school and I will follow your procedures and I will do your experiment. And you can collect your data watching me do it. And believe me, I know watching me do experiments is not near as much fun or at least semi-engaging as doing them yourself. But those are your options. Technically, I believe I have a due date of this for next Tuesday. I'd like you to work on this for the rest of this class period. And however, I know that some of you were trying to get some supplies together because you still wanted to do it yourself, even though you don't have everything available. But again, remember, I am not asking you to go buy anything. We can figure out a way to get it done otherwise. Um, So spend today working on the kitchen chemistry project, and on Tuesday we will start equilibrium, I believe. Let me know if you have any questions about this, and send me an email. I'll get back with email because I won't see y'all till Tuesday. So have a great weekend, and I will talk to y'all soon.